Hello friends, in this session we are going to discuss about Chomsky normal form. So basically, first of all we'll see its definition. Chomsky normal form, what is a Chomsky normal form? So it is a certain form of a particular grammar. So what does it say? It says that a context-free grammar G is in Chomsky normal form CNF if every production is of the form A goes to A, that is a non-terminal going to a terminal, and a single terminal. The point to note over here is we have a single terminal on the right hand side and a non-terminal going to two non-terminals. Both are written side by side. That is A goes to capital BC. So, and it also has an additional condition, which is S goes to null is in the grammar G if and only if null belongs to language of G. So basically what it means is that we'll be having a certain context-free grammar and we'll be checking its each and every production and identifying that if each and every production obeys these set of rules, that whether all the productions given in the grammar are in this particular format or not. If they are not, we would say it is not in Chomsky normal form, and if we have to convert it, we'll see how we convert it into a CNF. So let's move on to an example and straight away see how we do it. See, we have a grammar given to us and it has 5 productions. So these are the productions written. Now we'll be checking each and every production and identifying whether the productions are in the given format of a CNF or not, and the ones which will not be in CNF, we'll eventually convert them into a CNF. So if I see the first production, it is S goes to ABC. Now it says that a non-terminal is going to 3 non-terminals, but we saw that in our rule it was that a non-terminal can only go to 2 non-terminals, and that too when both the non-terminals are written side by side. That is, there is no terminal between them. So this first production is not in the given format and we'll need to convert it. So I've marked the first production. Then next, or I should cross it. Let's cross this. Now the next production, again it says S goes to AC. Now again the first element over here is a terminal, so it should have been of the form of this first production, but it also has a non-terminal on the right hand side of this terminal, which is not possible in the given format. Hence the second production is also not in the correct form and we'll have to convert it. The third one is in the same, it is basically the same production as written in the first rule over here, or I should say it suffices with the condition of a CNF. So this I've marked as a tick. We don't need to convert it into any other form. Similarly, the fourth and fifth production are of the same form as this first rule, and hence these also suffice with the condition and we don't need to change it. So basically we need to change only these 2 productions. First one is S goes to ABC and the second one is S goes to AC. Now, if I need to change this first one, since it is not in CNF, the problem is 3 non-terminals. So basically what I'm going to do over here is, I'm going to substitute 2 of the terminals, I'm going to replace them with a single non-terminal. So how do I do it? See, over here in place of S goes to ABC, I've written S goes to XC, where I have replaced this AB with a single X. So the next production that I'll have to add because of this X is X goes to AB. So with these 2 productions, 6 and 7, I have replaced my first production. Right, so I'll be replacing this first with the combination of 6 and 7. Similarly, to replace the second production S goes to AC, we can write down as S goes to YC and Y goes to small a. Right, so now what I'm going to do is I'm going to replace my first production with this combination of 6 and 7 and the second production with the combination of 8 and 9. Now another alternative possible specifically for this particular example is that instead of writing this Y, I would simply write S goes to AC, capital AC, remember this A was present in my grammar, and we already have this production A goes to small a in our grammar, right? So therefore we do not need to introduce a new non-terminal in order to substitute this small a. But this is only and only possible when A has only a single production of the form A goes to A and no other production on its right hand side. Had it been of the form A goes to A slash, let's say anything, x, y, and x goes to something and y goes to something, let's say x goes to small x and y goes to small y, I would not do the same thing over here. That is, I would not replace this s goes to AC with s goes to AC. This is because if I do so, I'll also have to substitute this xy over here when I need to convert this grammar into this form. So both the grammars won't be equivalent anymore. So that is the main point that we have to maintain till the end, that both the grammars should be equivalent, and we eventually do not make any change into our original grammar. We are just converting it from one form to another, but both the forms are equivalent, right? So finally our changed grammar is this. So I've just replaced my first production with this 6 and 7 and the second production with 8 and 9. So this is what I obtained from it. And if I perform the alternative thing that I had mentioned over here by replacing this second production with this 10th production s goes to AC and the first one with the same 6 and 7, I obtained this. So these are the final alternatives of the resultant that you could obtain. And now if you check it again with the CFG, with the CNF form, you would ultimately get to know that this suffices the rules or the conditions of a CNF, and hence this is a finally changed CNF grammar. So thank you friends, that's all for the session. Hope this session would have been proved to be an informative one for you. In case you have any queries or doubts related to the session, you can please post down the questions as comments under this post. And in case you like the video, please like it, and please keep following the channel for more informative videos coming up. Thank you.